Hey, welcome back to my YouTube channel. Today, I'm going to talk about balancing chemical equations in chemistry. This will be going from formulas and then from word problems. There's only 2 word problems. This video will be a long one, so just try to pay attention and maybe do these problems with me. Okay, so first what we're going to start out with this is this little acronym called MINO, which means metals, ionic compounds, nonmetals, oxygens, hydrogens. So when you're balancing, you mostly want to stick to metals, ionic compounds, then nonmetals, then oxygens, then hydrogens. But if you have anything by itself, if you have like hydrogen by itself, leave that for the end. If you have oxygen by itself, leave that till the end and like prioritize hydrogen. Or even if you have like ammonium by itself, you might want to leave that till the end. Okay, so let's start with a simple problem. All we have to do is obey the conservation of mass, meaning that there has to be the same amount of atoms on both sides for each element. You can't create matter and you can't destroy matter. So just keep the same amount of atoms. It doesn't matter how complicated the question is or how many coefficients you have to add. You just have to keep the same amount of atoms. Okay, so Li2O plus H2O yields LiOH. So that's like lithium oxide plus water yields lithium hydroxide. But you don't really need to know that. You can if you want to. Okay, so first we're going to start with our metals, which is lithium. There are 2 lithiums in this side. There's only 1 lithium on this side. So I am going to add a 2 here, meaning that this 2 distributes to the lithium and to the O and to the H. Now, we have our lithiums good, right? Then there's no ionic compounds and there's no nonmetals, so we're just going to move to oxygens. Well, oxygen, we have 2 on this side, right? 1 plus 1 is 2, and there are 2 on this side. You distribute the 2. Then, okay, now just check hydrogens. There's 2 hydrogens on this side, 2 hydrogens on this side. Another thing you can do if you have hydroxide on the side, OH, you can rewrite oxygen as water as HOH, meaning it's hydroxide, like bundled together, and then there's an extra hydrogen. That may be useful later today. Okay, now our next problem is HCl plus K2CO3 yields KCl plus H2O plus CO2. Okay, so let's start with our metals. Again, potassium, K, is our metal. There's 2 potassiums on this side. There's only 1 on this side. So we are going to add a coefficient of 2 here. Then we will move on to our ionic compounds, and CO3 carbonate is an ionic compound. So we check, okay, how many carbonates are on this side? There aren't carbonates, but we could just say, okay, carbon. Let's check carbon. There's 1 carbon on this side and 1 carbon on this side. Okay, we're good. Now let's check chlorine, because that's our other nonmetal. There's 1 chlorine on this side, there's 2 chlorines on this side. So we have to add a coefficient of 2 here to distribute. Now, we can check our oxygens. We have 3 oxygens on this side, 2 oxygens here, and an oxygen here, meaning we have 3 on both sides. So we're good. Now, we move on to our final element, which is hydrogen. There are 2 hydrogens on this side, and then if we look over here, there's 2 hydrogens here. So we are good, we are balanced, same amount of atoms of each element on each side. Okay, now Au2O3 yields Au plus O2. Well, let's start with gold, which is our metal. There is 2 atoms of gold here, so we need 2 atoms of gold here because there was only 1. Now, we have 3 oxygens, right, on one side, and there's 2 oxygens on this side. So you might say, oh shoot, how do I do this? You're like, 3/2 of O2. Technically, you could write that, and if that helps you, good. But what I'm going to say is, okay, find the least common denominator. And usually what that'll mean is just put a 2 in front of this, like just up that 1 more. And then this side will have an an even number, sorry, because like an even times an odd, an odd times an even will be an even. So then we can get like this O2 working. So this will be, now there's 4 golds, right? So we want to get rid of this 2. And we write a 4. So this is what balancing is. When you fix a problem, like getting the oxygen so they're both even, it usually creates a problem. So just go back, see what elements you changed, and see what you need to fix. Okay, now there's 6 oxygens on this side, there's 2 on this side, but if we put a coefficient of 3 here, that'll be 3 times 2 is 6. So we're balanced. Now FeS plus O2 yields Fe2O3 plus SO2. So let's first check with our metals. We have Fe, iron. So there's 1 iron on this side, there's 2 on this side, so we need a coefficient of 2 here. Now we can go to sulfur. There's 2 sulfurs on this side because the 2 goes to the sulfur. And there's 1 sulfur on this side. So let's move a 2 right there. Okay, now we can move to oxygens. There are 2 oxygens on this side, and there's 3 plus 4 is 7 oxygens on this side. Well, you can't get an odd number with an even number. So we're gonna have to up this 1 more. Well, actually, if you up it 1 more, you'll have Fe3, and this will be wonky. So you have to up it to 4, so that it's even, because you can only have an even amount of irons on this side. So this will be 4, meaning that there's now 4 sulfurs, meaning that this will be 4. And then we count the oxygens. Oh, sorry, this will be 2, because you have 4 irons. So now count the oxygens on this side. There's 6, 8. So there's 14 oxygens. There's 2 on this side. If we put a 7 here, you'll know you did everything right if, first of all, there's the same amount of atoms for each element on each side. And also, if these don't have like a common factor in them. So if this was like 8, you could divide them all by 2, but you can't. So we did it right. Okay, KO2 plus CO2 yields K2CO3 plus O2. Let's start with our potassium. 1 potassium here, 2 potassiums here. So we need a coefficient of 2 over here. Now there's 1 carbon here and 1 carbon here. So we're good there. There's 4 oxygens here and there are 5 oxygens here. Oh no, what do we do? Again, we have to bump this initial up. If we made that a 3, this wouldn't work because you can only have an even numbers of potassiums here. So that'll be a 4. Yeah, this will change to a 2 because you need 2 of these to make 4 potassiums. Now, if we move to carbon, there's 1 carbon here, 2 carbons here, so we need a 2 here. Now, we count the ions, well, the oxygens. There's 8 oxygens, then there's 4 oxygens, so that's 12. This is 6 oxygens. So there's a difference of 6 oxygens. Like this side has 6 less oxygens. Well, not really. It has 4 less oxygens. But if we put a 3 here, that'll make this 6 oxygens. All right. Now we move on to our last example of formulas, which will be NH4Cl plus CaOH2 yields CaCl plus NH3 plus H2O. So, first we can start with our ionic compounds. So I see that we have nitrogen isolated, so I might not do that till the end. I'm going to start with hydroxide. There's a hydroxide here, there's 2 hydroxides, and this H2O could be written as HOH, meaning like hydrogen hydroxide or something. You can write it like that. So there's 2 hydroxides here, there's only 1 hydroxide in each of these, so we put a 2 there. Okay, now if we wanted to move to NH4, we probably should have done calcium first. Sorry, there's 1 calcium here, there's 1 calcium here. Good. NH4. If we move to NH4, there's, well, we're not going to be able to get that by itself, but there's 1 nitrogen over here, there's 1 nitrogen over here. Good. If we move to chlorine, there's 1 chlorine here, there's 2 chlorines here. So we need that to be a 2. Now, if there's 2 nitrogens on this side, there's only 1 on this side, so we need a 2 there. Let's see if we disrupted anything. Still same number of hydroxides, still some number of calciums, still same number of chlorines, still same number of nitrogens. Now, let's move on to the hydrogens. There's 8 hydrogens here, and then this OH we're just going to keep together as hydroxide. So 8 hydrogens. There are 6 hydrogens here, and then there's 2 hydrogens because this is HOH, it's hydrogen hydroxide, there's an extra hydrogen there. So we have 8 hydrogens on this side. So we are good, we are balanced. Okay, now to the next section. Okay, part 2 of balancing chemical equations. we are going to be going from word problems to formulas to balancing. Okay, so I only really have enough time to do 2 of these, so let's make them good. First thing you're going to need to know, you're going to want to remember your your metals, ionic compounds, nonmetals, oxygen, and then hydrogen for like your order that you're going in. But another thing you want to remember is these new diatomic ions, meaning if they're ever present in nature, they are always like stuck together. There's always 2 of them. So these are hydrogen, iodine, bromine, fluorine, oxygen, nitrogen, and chlorine. So a good way to remember them is Hibberfonkel, which is nice, or you could use Braunfäckelhigh. Just remember one of them. I like Hibberfonkel. I like saying it. They're both fun to say. Just try to remember it or make your own combination of the letters. You can say a lot of things. Okay, just remember those. If you ever get hydrogen, iodine, bromine, fluorine, oxygen, nitrogen, or chlorine, it says like it's dissolved in chlorine or something. Remember, you're not just going to say like plus Cl, you're going to say plus Cl2. That's what diatomic means. So, our first problem, hydrocarbon hexane, which is C6H14, is burned in excess oxygen to produce carbon dioxide and water. So, the only thing that matters to us is hydrocarbon hexane, right? This first thing, and burned. That literally does not matter. Excess, like, is burned in, doesn't matter, whatever that says, is dissolved in, is burned in. Just don't care about it right now, because we're not onto that. Oxygen, to produce carbon dioxide and water. So to produce, to yield, to make, is the little arrow symbol. So you know you're going from reactants to products. Okay, so hydrocarbon hexane, right? We have C6H14, that's a bad C. Then we have, there's the excess oxygen, which will be plus. Remember, oxygen is our O in Fonkel and Hibberfonkel. So we're going to have O2, leave space for a coefficient if needed. Then to produce is our arrow. Carbon dioxide is CO2. CO2, leave space for a coefficient if needed. Plus water is H2O with space for a coefficient. All right. We have no metals. We have no ionic compounds. So we're going to start with nonmetals. Carbon. There are 6 carbons on this side. There's 1 carbon on this side. So if we put a 6 here, then we'll have 6 carbons on both sides. Okay, now we could move to hydrogen, but like I said, if you have just one of these elements like isolated, like if you have oxygen isolated, do hydrogen first because you can get to oxygen at the end. Okay, so there's 14 hydrogens on this side, and there are 2 hydrogens on this side, meaning that we need a coefficient of 7, because 7 times 2 is 14, to make 14 hydrogens on both sides. Okay, now oxygens. There's 2 oxygens on this side. There's 12 plus 7 is 19 oxygens on this side. Well, 2 cannot get to 19. Don't put like 19 halves or something. I don't even know. Just don't. You could put a fraction to help you, but again, the easiest thing for me is just put a 2 out in front of this, like your main term, your first term, and that'll cause the chain reaction to occur. So now there are 12 carbons, right? So there needs to be 12 carbons on this side. Now there are 28 hydrogens, right? Meaning that instead of a 7, we're just doubling everything we had. That 7 is going to be a 14. Now notice how 14 is even and 7 was odd. Now we have an even amount of oxygens on this side, meaning that we can get the same amount of oxygens on both sides. So 12 carbons, yes. 28 hydrogens, yes. Now oxygen. There's 2 oxygen on this side. There's 24 plus 14 is 38 oxygens on this side. Now all you have to say is, okay, 2 times what equals 38? Or 38 divided by 2 is what? Which is 19. So you're going to have 2 C6H14 plus 19O2 yields 12 CO2 plus 14 H2O. See, some of these problems can get complex, but you see we have the same amount of atoms on both sides, And none of these simplify, right? You would need a 2 to simplify this. So if these were all even numbers, you could simplify them by 2 and you didn't do it the simplest way. But as you see, you can't simplify these numbers. These are the simplest ratio of numbers. So this is the simplest way to balance this formula. So some formulas are just weird to balance, but just keep going back to that initial term if something's not working out for you. And if you just can't seem to balance something, your equation's probably wrong. You probably wrote something wrong. Like when I did this, I wrote HCO3 plus C6H14. The first time I did it, it's totally wrong. That's not, I just added bicarbonate for some reason. Just make sure you don't do like a little mistake, mess up a charge. Because if you've been working on a problem for like 5 minutes and can't get anywhere, like these even and odd things aren't working out, just check your equation. You're not going to have to check your equation when they gave you the equation, but when it's a word problem, check your equation. Okay, and our last question of the day. A precipitate is formed when solutions of sodium phosphate and calcium chloride are mixed to yield sodium chloride and calcium phosphate. Okay, so precipitate is formed, doesn't matter. Solutions doesn't matter. All that matters is our sodium phosphate, our calcium chloride, yield sodium chloride, calcium phosphate. Okay, so sodium phosphate, if we look at our periodic table, sodium has a charge of 1 plus. Phosphate has a charge of 3 negative. So this will be Na3PO4 plus calcium chloride. Calcium has a charge of 2 plus. Chlorine has a charge of 1 negative. So leave some space for a coefficient. CaCl2. Then we yield sodium chloride, which is NaCl, of course, table salt, plus calcium phosphate. Calcium has a charge of 2 plus, phosphate has a charge of 3 negative, so we have Ca3PO4, parentheses, taken twice. That's a little janky, but I think it gets the job done. Okay, start with our metals. 3 sodiums on this side, 1 sodium on this side. Make that a 3 there. Okay, now we can go to our polyatomic ions. We have 1 phosphate and 2 phosphates. So this has to be a 2 to make that 2 phosphates. Now, we just changed how many sodiums we had. Now we have 6 sodiums on this side, meaning that this 3 just got doubled and has turned into a 6. Okay, now we have our polyatomic ions. We have a metal. Now we have calcium to do, which I always forget. I always forget calcium. So there's 1 calcium on this side, 3 calciums on this side, meaning we need a 3 here. Now, we can go to our final thing, chloride. Oh, chlorine. There's 6 chlorines on this side, and there are 6 chlorines on this side. So we are balanced. I hope this video was helpful. Thank you so much for watching, and I hope to see you again soon.